Hello everyone, my name is Roopesh and my final project is multi-source Python parser for all the ETL jobs that we have and the ETL platform that I'm working on as part of my work. So just to give a background, as part of my work, we have a large-scale call center application that we support for all the internet and TV and voice orders. So our current persistent store is Microsoft SQL, and all the ETL jobs that we have are based off of MS SQL, like SSIS and the SQL job triggers that we use for processing all the data. So we recently started on our cloud transformation, and as part of it, we are moving to open source alternatives for storage, and that decision was to go with PostgreSQL. So PostgreSQL is going to be the store for all the application logs and the metrics from the application. So this gives me a good opportunity to try the Luigi workflow along with the Dask to build the platform of ETL. So that's where the idea came from. So for the project, I have picked up like few samples that I could use. Most of our data is like specific XML formats that we use. So I have picked up some parts of it and then to demonstrate the parser pipeline. So here are the tools that I have used. I have used like external tasks and then MySQL tasks, MySQL target tasks to write the aggregated data back, and then a custom target for XML to be able to read multiple XML files from the source, similar to our read CSV. Because I could not find anything that is already there for XML. So high-level workflow architecture diagram. So I have like 3 layers of tasks that are spread out across, and then will be responsible for doing all the ETL work. So the trigger tasks. These are the tasks that are identifying each source, and then they should be aware of how to connect the data, and then making sure the data is being able to be read from those sources in whatever format it is, like the XML or JSON or be it a database row. And then the next layer would be extraction tasks. These are the tasks that are responsible to convert into a single format. So the initial choice was to convert all the files to CSV. Then getting into this more into this project, I realized it is more efficient to use Parquet format than a CSV file. So I have decided, and I have converted all the XMLs and JSON files into Parquet files as the temporary store. So this Parquet files will be the feed in for the other parts, the subsequent parser tasks and the aggregation tasks. So a couple of things, because I have all XML data and JSON key value pairs, all of them can be converted into tuples. So that is what I have did. So all the source data is converted into tuples, and then all these tuples are stored as a column data. And then, which is like a lot more efficient reading the Parquet files and then combined with Dask parallel processing. So here are the code snippets that I have, and the XML target that I have implemented. So I did not find any equivalent to read XML files similar to read CSV that could actually take a glob pattern and read all the XML files from the source. So there is the pandas existing read XML. There is a read text for bag, but that is not efficient for Dask. So I have to implement my own read. So I have implemented using S3 glob, which will actually read all the XML file, and then I have used LXML for all the extraction part of the XML, and LXML, and then a similar task is done for JSON as well. So I extract, like for example, I have demonstrated a couple of nodes that I use and the subtags under the nodes. And then I convert everything into a Dask data frame. And this read is actually returning a tuples list of data frames, list of data frames. Internally, each of the data frame is actually a tuple for each file. as I mentioned, LXML is used for all the XML processing, and JSON, the native JSON is used for JSON processing. All the subsequent tasks are for aggregation and parsing columns. So I have created a configs for all the columns that are needed. So there is a list of JSON key value dictionary that has each level of the node and the columns that we need, which are equivalent to the tags or the keys in JSON and XML respectively. So these are the tasks that are based off of the config files, which drive the columns that are needed for the parsing. So this is how the initial parser looks like. All the tag names and tag values are parsed irrespective of the XML. So the whole XML is actually converted into tuples of tag name and tag value. And these are the aggregated tasks. Just to show, I can group by order types, like how many number of install customers came in, how many number of change customers came in, and how is the distribution across the states and across the line of business, which is consumer, business, etc. So high level, this is my structure that I have. So I have base files that are used for helper target files that I have overwritten, the XML targets and the parquet target and the base task target that we have from our psets, and combined with the custom tasks that I have written for this ETL. All those are part of these tasks. And this is how I am creating. We have the order number that is unique for each order, each customer. So I have used that to identify a unique folder structure for it, and each parquet file partition is actually a submit XML that I have. But it is more efficient in column format as tag value tag name pairs. So I have used pretty much like a lot of stuff that we have already used in psets, and it is very helpful to use patterns and then build this ETL pipeline. So I still have it running on my local scheduler for both of them. So probably I should take it up and do a central scheduling, which I am working right now. And then the other one is to process it parallelly and see how we can how I can still like process the output of it properly in each of the files. And these are my repos. And thank you for listening. Thanks for the opportunity.